This is GMAETS 41. Welcome to this live class on chemistry. In this class, we will be giving attention to a special aspect of atomic structure. Okay? We're giving attention to a special aspect of atomic structure. I'll be looking at the relationship between mass number we use A to represent the mass number, the relationship between the mass number, the atomic number, and the neutron number. Now, this relationship we are going to deal with in this class is very important because an examiner can actually try you on this part of chemistry. But the interesting thing is it's a very simple concept. Okay? Now, you would recall that on this platform, we had already treated the concept of atomic structure, where I taught you the fundamental particles of an atom to include the protons, the neutrons, the electrons. And we explained that the protons and the neutrons are known as nuclear particles. They are found in the nucleus of an atom, and they are responsible for the mass, the weight of the atom. They are responsible for the mass, for the weight of an atom. So when we talk about mass number, of course, based on what I've just said, that the nuclear particles, protons and neutrons, make up the mass, the weight of an atom. It simply means that if we want to get the mass number of an atom, we should be thinking of the nuclear particles. We should be thinking about the fundamental particles in the nucleus, which are the protons and the neutrons. Interestingly, you want to know that the protons, their number, okay, is the same as the atomic number of an element. I'm glad that on this platform also we have covered the part of the first 20 elements, all these under atomic structure. The first 20 elements, I remember talking about their serial numbers, their serial numbers, the first 20 elements from 1 to 20. I advised you, dear students, that you don't joke with that arrangement. You don't scatter them. When you are learning hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. That's the first 20 element. You want to learn more about all other elements, the choice is yours, where you have scandium, titanium, vanadium, chromium, manganese. But we are not talking about those ones anyway. The first 20 elements. I advise that it is never good. Yes, it is never good to learn this element in scattered order. Don't. Always give yourself a target. You can set a goal of 1 week if you don't want to overstress yourself. 20 divided by 5 is going to give you 4. So one can decide in 1 week, say, of 5 days. Yes, our 1 week is 7 days, but you might decide to say, okay, let's go on 5 days, so that even if I am not able to cover what I am supposed to cover, the remaining 2 days I can use it to make it up. So if we go by 5 days, 20 divided by 5, 4. So in a day, a student can decide to say, let me learn just 4 elements very well. because you are meant to learn these elements such that any day, anytime you are called to say them, you can say them without mixing them up. You need this very well. You need this very well. Chemistry organization sent me to tell you to learn the first 20 elements very well. The form foundational chemistry for you to enjoy this subject as a science student. So that serial number, that arrangement 1, 2, 3 down to 20, just like I have read out, is the same as the atomic number. Is the same as the atomic number 1 is hydrogen. If in the serial number 2 is helium, it means that atomic number 2 is helium. In that serial number, I know of sodium to be at number 11. It means that sodium has that atomic number 11. So if I ask you which element has atomic number 11, you simply tell me it's sodium. Chlorine is atomic number 17. Calcium is atomic number 20. And that is the way they are arranged serially in that first 20 element. So when a student knows this arrangement, the student has already learned the atomic numbers of elements. So do you see? I told you that proton and neutron, which are nuclear particles because they are in the nucleus, together they make up the mass number, the weight of the atom. So for mass number, if we want to get it, we need proton and neutron number. Simply put, proton plus neutron will give you mass number. Am I communicating? Then again, when you come down, the arrangement of these elements serially gives you the atomic number. And then a student is expected to know that atomic number is the same as proton number. Whether that atom has reacted or not, whether I'm talking about an atom or I'm talking about an ion. You know, ion is an atom that has reacted. Atomic number is the same as proton number. So knowing all these relationships, right, makes what we are about to deal with in this class today quite simple. So welcome to join this live class. Let me check the network condition as we kick off straight into the business. First, want to see what the way we, atomic symbol. Yeah, I'm going to show you atomic symbol. I'm not going to talk about atomic structure where you draw the circle and just atomic symbol. Okay. And then we start bringing out the formula that we need. After that, we solve some questions. And that's that for the class. So let me check the network situation. All right. I think the network is in order. Please, once you join the class, what stops you of liking what is happening? Hit the like button. Hit the like button. I don't like what I just saw in the camera. Hit the like button. Something good is happening. So once you join the class, like this class. Like it. This is one of the ways you can pay your school fees here. I'm not charging you school fees, right? Like it. Share the videos to your friends so that they can join. Good enough, I know that at least here in Nigeria, almost all schools, secondary schools, they are on break now. We're talking about preparing you ahead of your resumption September, okay? And I know also most universities are taking their second semester examinations now or about to take, so they will soon go on break, preparing for a new session where they will start all these things you're doing. So once you join this class, please like this class. Click on the like button, okay? Click on the like button, then share the link to this class. Share this video to other people so they can join and then benefit. All right, having said that, let us look at the general representation of our atomic symbol. The atomic symbol is generally given as this, okay? X is used to represent the symbol of an atom generally. It does not mean, we are not saying that there is a particular element that the symbol is X. No. What we are saying is, as just a general standard, I will say, okay, let us represent the symbol of an atom as X. So if it is hydrogen, that X will become capital H. If it is helium, that X will become capital H small e. If it is carbon, that X will become capital C. If it is boron, that X will become capital B. If it is calcium, that X will become capital C small a. If it is sulfur, that X will become capital S. If it is phosphorus, that X will become capital P. You know, when you are learning atomic structure, okay, the first 20 elements, electronic configuration, valence electron, and valency, you are meant to know the symbol of all the elements, at least the first 20 elements, okay? So that is it. Atomic symbol, generally we use X to represent it. So for any particular atom or element you are dealing with, you can now write the symbol of that element. Now this number written on top is called the mass number. You can see that, the mass number, which, like I told you, determines the weight of the atom. And it is made up of the proton number and the neutron number, the two nuclear particles. This Z here is called the atomic number. You can see that, atomic number, Z. Okay, atomic number. And then, of course, our N is the neutron number. You are not seeing the neutron number here. You are not. But the neutron number is hidden inside the mass number. Because like I told you, neutron number and proton number together will give you the mass number. All right. And don't forget that I've told you that atomic number is also the same, is equal to the proton number. So this is the general representation of an atom, atomic symbol. And I've told you the meaning of these two guys. This is mass number, and this is atomic number. So what are the various relationships that a student is expected to be aware of? See, these formulas are simple formulas, but sometimes students or educators, teachers, may just neglect this aspect of chemistry. Or maybe when they teach it, the topic is taught passively. Remember I said some educators, some students. I'm not saying all, but this is what I've observed many times. Some of us, we give little or no attention to this part of chemistry. And that is one reason why many students, by the time they start going to higher classes, they'll start complaining of chemistry. They'll start, having challenges with chemistry. The reason is because there are these key aspects of chemistry which somehow happens to be simple. And so for that reason, they just neglected it. Either some students do that, or some educators handling this part, they will just, copy note, and that's all. So many times, students don't just give serious attention to the importance of this part. And it ends up tormenting them, causing them trouble when they are moving to higher class. Please take this aspect of chemistry seriously, the foundational aspect of chemistry. Now, the first relationship I want us to understand here is the relationship between mass number, atomic number, and neutron number. The mass number A is equal to the atomic number Z plus the neutron number N. We are going to call this equation 1. Please take note of it. Now, having established this relationship, I had told you already that atomic number of an atom is the same as proton number. We are going to use P to represent proton number, whether the atom has reacted or not. So whether we are talking about an atom or an ion, it is always true that the atomic number Z is equal to the proton number. So permit me to write that, but Z is equal to proton number P. Okay, Z is equal to proton number P for atoms and ions. So it does not matter whether you are talking about an atom or you are talking about an ion. Remember, an atom, there is one electrical neutrality concept of an atom. We are coming to that. So whenever you hear atom, you want to know, or if an educator uses it, the educator, the teacher should understand that that guy has not reacted. Whenever an atom has reacted, we don't call it atom again. Rather, we call it what? A ion. So whether you are talking about an atom or you are talking about an ion, you want to always remember that atomic number is equal to proton number. So let me define this because I've not written it on the board, where P is equal to proton number. Good. If this is true, which of course it is, it means that it implies, it means, we are going to do substitution now. We are going to replace what? Z with P. So that whether you are talking about an atom or you are talking about an ion, in place of atomic number, you can actually conveniently put proton number there. So mass number can still be written as, instead of atomic number, we can now substitute, replace what? Proton there. Then plus N, plus neutron number. Let us take this as equation 2. No wonder I told you earlier that the two nuclear particles, which are protons and neutrons together, they determine the weight of the atom. They determine the mass of the atom. They give us an idea about the mass number A. So clearly we can actually say the mass number A is equal to proton number plus neutron number. See these two formulas, please don't play with them. Don't. They look simple. Besides, it's a formula. They are formula that contains only 3 quantities: mass number, atomic number, neutron number, or mass number, proton number, neutron number. But they are very important, necessary to the study of chemistry. Please don't joke with them. Remember the way our brain operates. When we passively give attention to this part, there's nothing here, nothing. Mass number is equal to proton number plus neutron number. Mass number is equal to atomic number plus neutron number. Okay, that's all. And you don't think about them. You will pay for it. And GMAETS 41 doesn't want you to pay negatively for these things that matter. They matter because the academic life, yes, depends on them. So remember, yesterday in our physics class, I told you that for this session, whenever I bring in a topic, it could be a topic you already have been taught, or you feel you know certain things about them. One of the key interests would be to emphasize. I will keep hammering it, stressing them, emphasizing on the importance of a particular thing in it. So that even though you want to play around every other thing on the topic, that particular thing, you wouldn't joke with it. Always, throughout your activities today, you want to continue remembering this. All right, so now I want to bring in another relationship. We've been talking about protons, we've talked about neutrons, we've talked about atomic number, we've talked about mass number. There are 3 fundamental particles of an atom: protons, neutrons, and the third one is electrons. But if you look at the board, there is nothing about electrons here. But I want to bring in electrons. What should you know about electrons with respect to the relationship we have on the board? So we are going to write a formula that can cover up with electrons or cover up for electrons. We'll bring in electrons in. But one thing is, if you want to introduce electrons into these formulas, you want to be very careful. I had said something about atomic neutrality. An atom is said to be electrically neutral. An atom is electrically neutral. What is the implication? What is the meaning of that statement that an atom is electrically neutral? Why will it be electrically neutral? The answer is simple. Whenever someone mentions atom, like I said, by standard, it means that that species, that thing called atom has not reacted. And for that reason, the number of protons will be equal to the number of electrons. Remember, protons are positively charged, electrons are negatively charged. If I have an atom, the atom is said to be electrically neutral because the proton number is equal to the electron number. The number of positive charges in the nucleus is equal to the number of electrons on the shells, on the surrounding. Am I communicating? And because the number of protons and the number of electrons are equal in an atom, the positive and the negative charges will cancel out. So there will be no charge again. And when you have any species, any substance where there is no charge, nothing like positive, nothing like negative, right? Then we say that that species is electrically neutral. Because what is responsible for electricity is this positive charge, negative charge. Are you following? Charges are responsible for electricity. So whereby the positive and the negative charges, they balance, that substance will be said to be neutral. So an atom is electrically neutral. Take note of that. And if that is the case, proton number will be equal to electron number. Therefore, I can bring in electron number here in place of proton number. But remember, that is for an atom. I'm stressing this because what I just said here is not true. I repeat, what I just said here about proton being equal to electron is not true for an ion. It's not true for an ion. If I'm talking about an ion, which is an atom that has reacted either by gaining electron to form cation, either by gaining electron to form anion, or by losing electron to form cation. If you have an ion, this statement is no longer true. For an ion, proton is not equal to electron. It's not. So what I'm about to do here to bring in electrons for protons is only true for an atom, which is electrically neutral. So let us write something. For an atom, like I say, whenever I hear atom, it is by standard electrically neutral. Proton number is equal to electron numbers. So our E, we are using it to represent electron. It implies that this formula number 2 can now be written as mass number A is equal to electron number. In place of this proton number, we'll now substitute it. We'll fix electron number, then plus neutron number. So this formula also exists. It exists whenever you're dealing with this relationship. The reason is because an examiner can decide to give you the number of electrons of an atom instead of the proton number or instead of the atomic number. Remember, proton and atomic number, they are the same, whether for an atom or for an ion, they are the same. So if an examiner is giving you a question on an atom where you apply these formulas, right? Now, an examiner can decide not to give you the number of proton, not to talk about the number of atom, that is the atomic number rather. The examiner decides not to give you these values and then go ahead and give you the electron number, the number of electrons. So if you are given the electron number, as long as that species is an atom, it has not reacted, that number of electron will be equal to the number of proton. And once you have gotten the number of protons, you have automatically known the atomic number of that atom. This statement is true only and only for an atom, because an atom is said to be electrically neutral. And the idea of electrical neutrality of an atom is because The number of protons is equal to the number of what? Electrons. Please take note. E is number of electrons. So let me write it here, where E equals electron number. Electron number. Please, for an ion, proton number is not equal to electron number. So let me give it to you as a note. So you want to be warned about this. Note. For an ion, so either cation or anion, in bracket, cation or anion. Cations are positive ions, and anions are negative ions. For an ion, proton number is not equal to electron number. It's not equal to. Take note of that. For what? Ions. Having said this, it is going to take us to the last relationship you want to take note of. If for an ion we say that the proton number is not equal to the electron number, how can we actually determine the number of electrons? Because where the problem comes in for an ion, where the problem comes in is with this electron number. Because for ions, they either have excess electrons or fewer electrons than what it is supposed to be. For example, if I talk about cation, the number of electrons in cations is always less than the number of electrons that the atom of that ion has. I'm going to give you an example. Sodium, for example. You see sodium? If I write sodium like this, this is an atom. This is atom. This is atomic sodium. The number of electron is equal to 11. There are 11 electrons there because sodium is atomic number 11. But you see this one. If I write sodium like this, if you want to pronounce this, this shows that you can see that there is a plus on top. We call it ionic charge. We call it what? Ionic charge. This shows that this sodium is no longer sodium atom. It's simply telling us that the atom of sodium in this case has reacted. So it is no longer this form. In this case, the number of electrons is equal to 10. Are you seeing the difference? This plus you are seeing here, just 1 plus 1, shows proton, excess positive charge compared to negative charge. Like for sodium now, the positive charge will be 11 because the number of protons will still remain 11. Positive charge. I'm so sorry. The network messed up. This is so annoying. This is annoying because I'm sorry, the network messed up. I don't have my tracking device, so I couldn't determine when the network interfered. I don't have my tracking device, so I could not determine when the network interfered. But I just found out that you friends have been logged out since. I am sorry about that. Remember, I have always advised that patience is needed. Whenever this network is messing up, don't worry. See, that's where we find ourselves in this part of the world. Okay. But one thing is GMAT 41, we don't give up. And you guys are GMATs, so you don't need to give up, right? You don't need to give up. So this is what is going to happen. I'll still go check the network situation. But I've actually explained a lot of things. So I don't really know where the network dealt with us from. So this is what I want you to do, please. Somebody should type, where did the network interfere from? I had taken my time to explain a lot of things here. Very important, trying to differentiate between atoms and ions. Are you getting me right? So, but I don't know if you followed up. And what I really explained here, very important. So please, I don't have my tracking device. So I want to go to check from the camera. Someone should please type, where did this explanation stop? Where did you stop, following up? Where were you cut off? So that I will know what to quickly do. We don't have time, please. Somebody should do that. Someone should type, please. I don't know, Mary Cynthia, Faith David, Veron Mithran. Please, can someone indicate where the network cut us off from? Someone should just type it, please, 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 please. I don't have my tracking device to determine where it affected us from. So you people are the only one to save the situation now. Otherwise, I'll continue from where I stopped. But what I explained on this part of the board is very significant. Very, very significant. Okay, because I was using it to highlight, explain the reason why this formula number 3 can only be used for an atom. You cannot use it for an electron. You cannot use it for an ion. You can't. Because for an ion, the number of electron is no longer the same as the number of proton. For an ion, the number of electron, you see, we are suffering one thing about network. These people, power holding company, have started theirs. It's not funny. Anyhow, people. All right. So, for an ion, the number of electron is either less than or greater than the number of electron that the atom of that element has. That is why this formula can only be used for atom analysis in this relationship. You cannot use it for ion. So I wrote this thing out to show you what I mean by saying that electrons and protons are not the same for ions. They are not the same. They are not the same. This thing is cation. How did I get to know? Because of the positive charge, plus. Meaning that the atom lost electron. If sodium, now look at sodium as an atom, look at it as an atom. There is no charge as an atom, no charge. So this is an atom, sodium atom. The number of electrons and the number of protons will be the same, 11, 11. When sodium atom reacts, this is what you are going to see. You write it as sodium ion, you'll be seeing +1. If it is 1, you don't write the 1, you just write plus. This simply shows that sodium lost electron, lost 1 electron. So do you see the number of electrons in sodium ion becomes 10? But in sodium atom, the number of electrons is 11. So you see the electron number in the ion. For this cation, it reduced. All right, so someone should post, please. Let it not be that I'm repeating the same thing. No one has indicated where the network interfered. So let me just quickly highlight this again. Okay. Then look at example of oxygen. Oxygen is atomic number 8. So for atomic oxygen, it has 8 electrons. It has 8 protons. You can see that 8, 8. 8 electrons, 8 protons. But when oxygen reacts, it gains 2 electrons. And how do you know that it gains 2 electrons? The ion of that atom will now be written like this. You can see 2 minus on top. You can see 2 minus. Once the ionic charge is 2 and above, you must write that number before the sign, whether plus or minus. Okay? You must. Like aluminium now, aluminium is written as Al3+. I hope this did not cut off. Aluminium, Al3+. Okay, it didn't show completely. Al3+. So that Al3+ shows that aluminium lost 3 electrons. That is aluminium ion. If it is aluminium atom, you won't see that 3+ there, you won't. Okay? So once the ionic charge is 3 and above, is 2 and above rather, you must write that number before the charge. Must write that number before the charge. But if the ionic charge is just 1, you don't need to write 1. You don't need to write that number. Just write the charge sign. So for oxygen, oxygen here gained 2 electrons. This minus means it gained 2 electrons. The idea is the negative charge in oxygen ion, the negative charge in oxygen ion, which are the electrons, they are greater than, they overpower, they are more than the positive charge, the protons in the ionic form. So you see, oxygen ion, the proton number is T8. But look at, it is T8 like the oxygen atom. But look at the electrons. The electron has increased from 8 to 10 because ionic oxygen is simply oxygen atom that has reacted and gained 2 electrons. So the whole idea is this. I was just trying to give further information about this. Proton number and electron numbers are not the same for an ion. And for that reason, you see this formula number 3, you cannot use it for an ion. You can't. You can only use this for an atom. For you to use this formula 3 for ion, there is another relationship you must know, which is the last relationship I'm going to show you. Then we'll pick 1, 2 questions and solve. I'm sorry, the network interfered. We're going to be fast in what is left. Let me check the network situation as we move on. Please always remember that you need to be patient whenever network interferes like this. I will always boost the network. I have my own way. This is GMAETS 41. I know what I do, something to boost the network once the network goes down. So you want to always be patient. Once the network goes down, automatically you will be logged out. But when I boost it and it comes up, automatically again, you will be logged in. So always stay on. The only thing is, it will be punishing me to be going back and forth, What do I mean? Going to check the network situation. Let's look at the last relationship you are expected to know. The last relationship you are expected to know. If you are dealing with an ion, for an ion, we want to find out how you get the number of electrons for an ion. Because if I give you an ion, the electron number is no longer the same as the number of electrons in the atom. It is either the electron number of the ion decreases. You can see that of sodium decreased from 11 to 10. Or it is either the number of electrons increases. You can see that of oxygen, it increased from 8 to 10. Generally, in the case where the electron number decreases, that happens to metals. That happens to metals. Don't worry. In one of my fun class under our YouTube short, I'm going to explain to you friends, especially the younger ones coming up, how do you identify a metal? And how do you identify non-metal? Whenever the number of electrons decreases, where you have plus for the ion, that atom is a metal. Whenever the number of electrons increases, where you get negative in the ion, it means that that atom is a non-metal. So the number of electrons is not the same in an ion and in an atom of a particular element. Therefore, for an ion, how do you get the number of electrons? So for an ion, electron number E is simply equal to, we are going to link it to proton number. So it is equal to the proton number, then plus or minus the ionic charge. Plus or minus ionic charge. Good. I don't know how many times any of you have seen this formula before. So let us call this equation 4. If I give you any ion and I want you to get the number of electrons in the ion from the proton number or from the atomic number, remember that P here is proton number. It's the same as atomic number. Okay, let me still write an alternative form. Or you can say that electron number is equal to atomic number plus or minus ionic charge. Good. Plus or minus ionic charge. This is still the same as, okay, let's call this equation 4a and call this equation 4b. They are still the same thing because you know that proton number and atomic number are the same. Okay? Good. So if I give you any ion, and you want to calculate the number of electrons that ion has, maybe you know the atomic number or you know the proton number of the ion, because atomic number does not change. Proton number does not change, whether that element is in atomic form or whether it is in ionic form. Proton number and atomic number remains the same. They don't change. It is electron number that will be affected. So if you want to get the electron number for ion, all you just have to do is go to the proton number or go to the atomic number of that ion. Then either you add or you subtract the ionic charge. Now let me check the network situation before I break down this formula now. Because you need to know when do you add the ionic charge. You need to know when do you subtract the ionic charge. But before I explain that, let me go and check the network situation so it doesn't cut off, because this is very important part, fundamental part of this formula as we now take a question. All right, good. I think the network is still cooperating. Now, a student may wonder, looking at this, when will I do electron number for an ion is equal to proton number plus ionic charge? When will I do that? Or atomic number plus ionic charge? When will I do that? A student might be wondering, okay, when will I do electron number is equal to proton number minus ionic charge? Or atomic number minus ionic charge? It is simple. When the ion is cation, when the ion is what? Cation. That is to say, I give you a positive ion. To get the number of electrons, you will do proton number minus ionic charge. So for cations, the formula will be minus ionic charge. And simply for anion, when you see negative, are you following right? Anion, the formula we go with positive. The reason is this. Remember that to get a cation, that atom loses electron. Losing is now minus. That is why for positive ion, for cation, you are going to go with P minus ionic charge or Z minus ionic charge. Because in that case, positive ion, the atom lost, and losing, you minus in calculation. Then if it is anion for negative, I've told you that in the case of negative ion, the atom gained more electrons. And you know, for calculation purpose in mathematics, gaining is plus. So if I give you a problem to get the number of electrons in an anion, negative ion, since that atom gained electron to become negative ion, gaining means you're going to use the plus. So let me conclude this relationship analysis by writing notes. For cations in brackets, positive ions, add the ionic charge. Add the ionic charge. Oh no, for cations, subtract the ionic charge rather. You subtract. Subtract the ionic charge. Ionic charge. Then for anions, in bracket negative ions, add the ionic charge. You see, this class, this live class that I've just hosted and this stuff, this is something that many scholars, all right, from grade 10 and above might have met all right, feeling that they know more about it and other things. But most times, because of not giving serious attention to all these things, relationship I've just brought out, an explanation I gave, when an examiner asks simple questions on this, yeah, the questions are usually very simple. You see students just thinking too much to answer the question. Why? Because they've not allowed their brain to really understand the concept fully for what it is. So, dear friends, I want you to give attention to all these things we've explained, this relationship. So once you're given any problems, or anytime you want to analyze or explain anything about it, you just play with them. Nothing is there. They're just 1 + 1. So we are done with the whole analysis. You need to know under this relationship. We shall just pick few questions and then I'll solve and round off. I have a physical lesson to attend to. All right, here in Nigeria, for our Nigerian friends. Then those from other country connecting to our live class, here we take professional exams, WAEC, NECO, JAM, GCE. So I have the class by 10:30. It's supposed to be by 10, but I adjusted it because of this live class. Okay, and then for those of our friends in this physical lesson that I'm going to attend to by 10:30, remember, some of you missed this class. In this class, like I say, is very important to the study of chemistry. I actually also came on live this morning so that you can learn from it. If you missed the class, you've actually learned from this live class on what we treated. And if you attended the class, as humans, chances are that there are 1 or 2 things you may have forgotten. Here, the GMAT 41 has reminded you again of them. Let's pick some questions as we conclude the class. Let's pick some questions as we conclude the class. I'm not going to waste time on this. More questions I'm going to solve will come through our fun class under these platforms, these channels, YouTube Shorts. Please, whenever you visit GMAT 41's channel, check the homepage. You will see home video, shorts, live playlists. Okay, I think something else about a post or so. So look at those things. You have videos on each of those sessions. Okay, yeah. The homepage shows you everything about an overall view of the channel. Then you move on to videos. You have all the videos on this channel. So many. Like I said, GMAT 41, this is not just a kind of, I don't know how to put it more. Just know that this is a full online school. You see the pattern in which I teach, right? Breaking concept down, what you are being taught, or your scheme of work in school and other things, and the things you are really meant to give attention to. So please, make use of this channel to the fullest. Understand the way the channel is being arranged. Like I said, you have the video section, you have the playlist section where, the subjects have been arranged for you. You have the live section, all our live classes, the videos are there under the live section. You have the short section, all these short videos, okay? I use it to have fun sometimes. So like I said, the questions we're going to solve, just very few questions. So other ones will come under YouTube Shorts. Question number 1. Find the number of protons, neutrons, and electrons for the following species. Okay, for the following. So we're going to have A. Let's talk about, so which one will I give to you? Okay, calcium. So I have 40, I have 20, then Ca. That's calcium. Then I am going to give you B, calcium ion, written like this. Then let us have C. Let's consider a negative ion. How about I go with Should we go with fluorine and C? Fluorine, right? Or let's go with phosphorus. Phosphorus, 3115 P, phosphorus. And then we have D. Assume that phosphorus now reacts. So let's say I have something like this. So you see what I try to do? I have the atom of the element, and then I have the ion of the element. Let us see how we can get the proton number, the neutron number, and the electron number. Okay, so it's a simple question, it's a simple problem to deal with. Solution, let us see how we answer this question quickly. So the first part of the question, without wasting time, you see what we have here is calcium ion, and we have the mass number to be 40, the atomic number to be 20. Remember, the general representation of an atom, X. Then on top you have A, below you have Z. A is the mass number, here is 40. Z is the atomic number, here it is what? 20. So for this question, you know that your A is equal to 40 mass number. Writing all this is a waste of time. Just trying to show you, then the atomic number is what? 20. Good. Now we have to find the proton number. Proton number P for an atom or for an ion is equal to atomic number Z. So if the atomic number is 20, the proton number of calcium will also be what? 20. So we have obtained the proton number. Very simple. Nothing is there. Now the neutron number. How do we get neutron number? The neutron number will be the mass number minus either the proton number or atomic number. Remember formula number 1, equation 1 or equation 2. We have that mass number is equal to atomic number plus neutron number. If I want to get neutron number, it is simply to make neutron number subject of the formula. The neutron number, to make it stand alone, subject to the formula, you move Z to meet A. If this Z crosses to meet A, because there is plus between this Z and what you are looking for the neutron, because there is plus. You talk about collecting like terms. If Z moves to mass number to A, to the left-hand side, it will become A minus Z. So that's what I'm doing here, right? Just straight on. Instead of writing the formula out like this, you already know the formula, so no time. Our A, mass number is 40. Our Z is 20. So with this, you find out that the neutron number is what? 20. Because if you do 40 minus 20, you get 20. Then finally, the number of electrons will now be equal to, remember for an atom, this is an atom. That is why there is no charge, no electron, no ionic charge there. So this is an atom. And for an atom, we say the number of electrons is equal to the proton number, the same as the atomic number. Whereas the proton number or atomic number is 20, it means that the electron number is also what? 20. We are done. We can now conclude, therefore, that the proton number, neutron number, electron number of calcium ion is, of calcium atom rather, not ion, of Ca, calcium, is equal to, the proton number is 20. So I want to arrange the answer in the order the question was given. The neutron number is also 20. And then we have the electron number to be 20. So everything is 20, 20, 20. That's the answer. So look at it, copy it out. You can screenshot because I'm going to wipe so that we can solve for, will I be able to manage this part? Let me check. Thanks a lot for your live video. I think it's helped a lot. Thank you very much, Sam Onofere. You're welcome to join the class. It's good to have you here. Please remember to help us share this video to your friends, to your classmates, okay? So that they can also benefit from it. I also want to use this opportunity to inform you that I have launched another channel where we tell reality. We tell reality. That's the name of the channel. Tell reality. Capital T, capital E, capital L, capital R, and then the reality spelled in small letters. Let me show you, please. Tell reality. Yes, you need this channel. because I have decided that on this academic channel, I'll be doing less of talking about advising, and other things, because it affects our lessons, making it so long. We come here, we know we are here for business. I teach you. For advices that will help improve your life, academic life, social life, moral life, emotional life, mental life, physical life, spiritual life also. Please, on this channel, tell reality. Okay, the username is @omaka_emi, @omaka_emi, because my name personally is Omaka Emmanuel. Okay, although here on this platform I go by GMAETS41. So tell reality, type and search it on YouTube, and please subscribe. There we talk about life reality. This T represents truth, E education, L life, and then reality. Tell reality. Okay, you will love that channel. Today I'll be dropping one video, okay, where we talk about the breaking relationship. The breaking relationship between parents and the child, how it affects the child, the common patterns that are being prioritized over truth, which is not true, okay, that is affecting, the child today. So please subscribe to that channel. I really appreciate it. Okay, meanwhile, let's get back to our business here. That channel is meant to be advising you and encouraging you on life's reality. Okay, so let us look at the B part of this question. I want to be sure that this does not cut off, and I hope the network is still respected. Let me see if I can adjust a bit. Let me see. Now, let's see. Okay, I think I have to bring this here. B part. Okay, B part we are solving for calcium ion. Calcium ion. How do we know that this is calcium ion? You can see the ionic charge. So for calcium ion, we want to find the number of protons, neutrons, and electrons. How do we approach it? Is simple. Going for the number of protons. Remember, for an ion, the proton number is still the same as the atomic number. Calcium is atomic number 20. So proton number will be equal to atomic number, which is 20. So whether calcium has reacted here, that calcium has reacted here rather does not matter. Okay? It does not matter. The atomic number still remains the same. So the proton number will still be 20. We have obtained that. Then the neutron number will still be the mass number minus the atomic number Z. But permit me this time around, let me use proton number. Remember, you can still use atomic number. Formula number 1 and 2, they are the same thing. And you know that proton number and atomic number are the same, whether for an atom or for a ion. They don't change. So the neutron number here will still be 40, which is the mass number of calcium ion. Mass number also does not change, whether it is an atom or an ion. It doesn't change. So it is going to be 40 minus proton number 20, so that neutron number is still 20. Interesting. Proton number, neutron number, 20 still for the atom and for the ion. Let us see what happens to the electron number. Coming to the electron number, remember, this is where you want to be careful now. This is an ion. This is an ion, not an atom. This is not calcium atom. This is calcium ion. So I can't pronounce this as calcium like that. No, it is not allowed in chemistry. I can't pronounce this as calcium. Look at this one. I can pronounce it calcium and just leave it. Somebody will know that it is calcium atom. But you see this guy? If you have to pronounce it calcium, you must add ion to it. Calcium ion. Calcium ion. That is how someone will know that you are referring to calcium that has reacted. This is 2 plus, showing. Remember that plus means it lost electrons. How many electrons? 2 electrons. So because this is an ion, you can no longer use this relationship we used in the case of the atom. E equal to P. You can do that. In this case, you're going to write E equal to P. Because this is a cation, it lost electron. You're going to do minus ionic charge. Minus ionic charge. So in the case of cation, where you have positive, you have to subtract the ionic charge. Don't forget, because that thing can confuse you if you're not careful. Positive, you now think you are adding. No, you are subtracting the ionic charge. So the number of proton is 20 minus the ionic charge is 2. So if you do 20 minus 2, you will get 18 electrons. This is interesting. Concluding, therefore, protons, neutrons, and electron of calcium ion is equal to the proton is 20, the neutron is 20, and then what did we find out about the electron? 18. Which, of course, makes a difference between the ionic form of calcium and the atomic form of calcium. You notice that the electron number has been affected. Let us conclude. Now, look at what is going to happen. I will leave you to solve question number 30. Sorry, question number C. At the end of this live video, a copy of this video will be made available. So you can come back and drop your answer. Solve it there in the comment section. Solve it. Solve it. Our physics class yesterday on quantities and their units, I dropped 10 questions, 10 solid exam-related questions in the comment section for you guys to answer. Make sure you always come back and check comment section for whatever I update there for you to do. So I will leave you to solve this C, right? I'm going to solve D part, phosphorus ion. Let me finally check the network situation that you are still on as we conclude. Please, I want to boost the network a bit. I want to boost the network a bit. Stay on. If you are being logged out, you'll still be logged in. All right. So I think I've got to adjust this a bit, just a little. Good. I noticed that the network cut off some persons, so I needed to boost it. Let us conclude. I've solved for calcium ion, like I said. So look at it. Please take note of what we did in getting the number of electrons for calcium ion. Let me go to D part now. I will leave you to solve C part. Like I said, at the end of this class, a copy of this live video will be made available. So you can always check back, then solve C part. I'm solving D part. What we have there is phosphorus. And you see 3 minus, that is phosphorus ion. Now, the mass number of phosphorus is 31. The atomic number of phosphorus is 15. Phosphorus is atomic number 15, okay? All right, the network is still on. All right, someone has already, Asma Yusuf, phosphorus atom, proton number is 15, correct. Neutron number is 16, correct. Electron number is 15. That is very correct. Someone has already solved and dropped this. Yeah, because he has said the answer. That's good. All right, but I'd like you to solve it. Drop your answer in the comment section, but you can only do that at the end of this class so that I can see your comment. It will be there, okay? All the comments you make now, this is a live class. At the end of it, they will disappear. They'll go off. All right, let us round off, please. Phosphorus ion. So we start with the proton number. Proton number, as usual, is equal to atomic number, and the atomic number of phosphorus, whether ion or atom, is 15. So I'm going to write 15. Look at it here. That is why your first 20 elements, you don't joke with them. Please memorize them. Cram them in that order, 1 to 20. Okay, now this takes us to the neutron number. The neutron number is simple. Just do the mass number minus the atomic number. And if you come to phosphorus atom, because phosphorus ion, the mass number is still the same as the atom, as that of the atom. And the atomic number is still the same as the atomic number of the atom. So it's going to be 31, 15. So simply do 31 minus 15 straight on. Anyway, let me write it. A minus Z. So neutron number will give you 31 minus 15. Remember, this is what we are solving for. But like I said, the mass number and the atomic number is the same as that of the atom. So if you subtract this, you get 16. Okay. Then finally, the electron number. The electron number will be the proton number or the atomic number. Look at just like I did here. Proton number or atomic number. This P is proton number. Permit me to use atomic number this time around. Z to represent proton number. Now, what did I notice here? The ionic charge here is negative. Since you have negative, it means that phosphorus actually reacted, the atom reacted to gain 3 electrons. The minus ionic charge means it gained. And because it is gaining, you add. So plus ionic charge. So this is the relationship. So the number of electrons will now be atomic number, which is 15 plus ionic charge. And ionic charge is 3. Okay, that's the number of ionic charge is 3. If you do this, you get 18. Good. So the number of electrons that phosphorus ion has is 18 electrons. But phosphorus atom will have 15 electrons. We conclude, therefore, protons, neutrons, electrons of phosphorus ion will be equal to, I hope this has not cut off. I hope network has not interfered. All right. We are grateful to our God and helper, Jehovah, for helping us because we have conquered the network situation once again today. That's the GMAETS. I want all of you to be GMAETS 41 wherever you are. Don't give up. Be tough whenever situation is getting tough. That is how you succeed. Proton is 15, neutron is 16, electron of phosphorus ion is 18. So this brings us to the end of today's live class. And I hope you enjoyed the class. I hope you learned something. So let us applaud our effort in the class today so far. With this, there is no problem on this concept you cannot solve. Now, let me give you an assignment. I'm just going to dictate it. I'll dictate it. Pay attention. Because it is not always that the atomic symbols will be given to you with, these numbers. It can be presented in grammatical form. It can be presented in grammatical form. Remember, solve this one. Solve this one. Solve this one. Okay, solve this one. Now, this is a question. An atom X. An atom X. So you see, I've called the atom X. It could be any atom. So you listen and follow. An atom X has a mass number. Has a mass number of 27. An atom X has a mass number of 27. I hope you've written that down. If the number of electron is 13, find proton, neutron, and atomic number of X. Find proton, neutron, and atomic number of X. That's the first question. Question number 2. I will link that question number 2 to question 1. Okay? Question number 2. If the ionic form of X in question 1 above, if the ionic form of X in question 1 above is X3 plus, is X3 plus, is X3 plus. If the ionic form of X in question 1 above is X and then 3 plus, find proton, neutron, and electron number of the ion. And electron number of the ion. Solve this question. drop your answer in the comment section below. You can only solve this question. This is a live class, okay? So once it ends, a copy of the video will be made available, like I said. So any other person that comes later to take this video will be taking it as an uploaded video. So drop your answer in the comment section. I'll be there to access it and see how far you understand this, okay? Thank you for connecting to the class, and I'll be seeing you in our next class. Remember, we have a timetable guiding us on this online class. Check out that by visiting the community of this channel. You would see the timetable. Have a lovely day. Bye.